Class, here's a simple program that demonstrates a loop. You'll notice that the program starts by assigning a value of 0 to a variable count. That's going to be our loop control variable. Then the loop starts. The loop then will execute through these symbols. As you can see, we've got 3 symbols inside the loop. And if the loop continues, it'll continue to cycle like this. So you can see why we call this a loop. Let's look at the statements and symbols inside the loop. First of all, we have an output, which is going to output the current value of the loop control variable count. And then we have a conditional test. If the count is greater than 9, program control will exit out the yes branch, and this program will stop. If, however, this is not true, if the if the count variable is 9 or less, program control will continue out the no block, and this will add 1 on to the value of count. This is an assignment statement that's going to increment the count variable. Take the count variable, add 1 to it, and reassign it to count. Let's see how it runs. And we'll watch the watch window. Here's the watch window, and you can see the value of the count variable changing as the loop cycles. And you can also, of course, see the output here. Now, as soon as the count is greater than 9, this program is going to stop. There it is at 10. You can see over here our count value is 10, and our program has stopped. We got the output from 0 to 10. And it indicates 46 symbols were executed because of the number of times it went through the loop here. This is one of the reasons why we value loops. You can repeat blocks of code very easily with a loop. Tasks that a human would find unbearable, we can have a computer do without any problem with a loop. Let's make a couple of changes. What if we were to take this value count here, this incrementer, and try to drag it up above the condition? Okay, so now I'm going to put the increment variable here. I'm going to increment the counter before the test, before the conditional expression here. Let's run that again, but in order to save some time, I'm going to run it compiled this time. On the Run menu, there is a choice here, Run Compiled, which allows your program to compile and then run more quickly instead of being executing statement by statement. There it is. And you'll notice that we get the output this time from 0 to 9. That's because we're incrementing the count variable before this test. So it actually runs 1 less time than the previous one. We could do other things. I could, for example, drag this down here, perhaps. And I wonder what sort. This is totally messing up where I had my comments, of course. But let's see what that gives us as output. Once again, we'll do this compiled for speed. We get from 1 to 9. You'll notice this time, because we've incremented before the output statement, the first time through the loop, count gets incremented from 0 up to 1. And so we don't get a 0 in our output at all over here, as you can see. Okay, this is how loops work. There's lots of things you can do with them. They're extremely powerful programming tools.